All right, so take a look at this. We did do these functions before. We're looking at the graph, so we're just kind of reviewing it a little bit again. So our two radical graphs we have are the square root and the cube root. So if you do not have your calculator, get that handy. So our parent function for our square root is just simply f of x equals the square root of x. That's our most basic form of the square root function that we can get. So let's go into our calculator. Clear that out. Second x squared to get me my square root of x. And then again, that's our shape of our graph. It's that little curve there. So I'll use my table to get me a few points. So we got 0, 0. I'll copy that over here. 0, 0, 1, 0. 4, 2. And then 9, 3. Arrow over there on that right side. Label it with your function. So in this case, f of x. So what would be our domain of this function? Is it ever going to be negative? No. But it is clearly 0 because we have a point right here where x is 0. It is a filled endpoint, so that does actually happen. So our domain is going to be x is greater than or equal to 0. If you remember back in Unit 2, this was one of our restricted domain cases where you took the stuff under the radical and set it greater than or equal to 0 in order to solve. What would be our range values here? Y is greater than or equal to 0. Also, the lowest our y's are going to get is that 0 value. There's not going to be anything lower than that. So our endpoint for this would be at 0, 0. There is no left side end behavior here. So if they did ask you a question about the end behaviors, you really can only talk about the right side because only the right side of this graph is going to continue on to a value, which would be positive infinity. It'll take a while, but it will be approaching positive infinity. And again, there would be no left end behavior here because you have that end point. It doesn't keep going on forever. So let's take a look at our transformations again. So if we have f of x equals the square root of x plus 1 minus 3, what are those two transformations that are happening? Left 1, and then down 3. So we can take that parent function that we just graphed up above and move each of those points that we plotted left 1 and then down 3 to be able to create our new graph. So left 1, down 3, left 1, down 3, left 1, 1, 2, down 3, 1, down 3. So moving everything left 1, down 3. We use those transformations to do that because a lot of times it's a lot quicker than typing and retyping everything into that calculator. So what would our domain be this time since we shifted it to the left 1? Yep, x is greater than or equal to negative 1. And because it went down 3, what would be our range now? Yeah, greater than or equal to negative 3. And then our endpoint this time Also went to the left 1 and down 3, so that is at -1, -3. Would we have a left end behavior yet? No, we still don't have an arrow on that left side. We would just have a right one if they asked for it. So just the right side. That function, again, is still approaching infinity. So in our second one there, what are those two transformations that are happening? What does that negative out in front do? Yes, reflect over the x-axis. And then the +6 makes that graph go up 6. So again, if I take my parent function, my first point was right here at 0, 0. If I reflect it, it's still at 0, 0. So I go up 6. Yeah. So then our second point was at 1, 1. If I reflect it, it's now at 1, -1. And then I move that up 6. And then 4, 2 gets reflected. And then up 6. And then 9, 3 is reflected. And then up 6. Got it wrong on that one. So what would be our domain this time? Yeah. Perfect. X is greater than or equal to 0. Now, because I reflected this one, my range is going to be slightly different. This time our range is going down. So this is going to be a less than or equal. And it's going to be at 6 because my highest y is a 6. Yes. So we got 0, 6. 0, 6. 1, 5. 2, 4. And then 9, 3. Sorry, I inverted that for some reason. 4, 2, not 2, 4. So then our endpoint is at 0, 6. Again, there would not be a left end behavior. This would still be the right side is going to infinity. So as our square root, that was one of our restricted cases because, again, you can't take the square root of a negative. When we take the square root of the negative, we get imaginary numbers, which would not be on the same graph as these. So then our other radical would be the cube root function. That's the other graph that we deal with. I know in Algebra 1, you did graph this a little bit. We did have to practice graphing this back then. So let's go ahead, graph it, take a look and see what it looks like in the calculator. So again, if we push the math button, option number 4 gives us that cube root. And then we put our x underneath. And then if we take a look at a graph, this kind of looks like a little snake there. So let's see here. All right, so I'll start off with -8, -2. -8, -2. Skipping over all the decimals. -1, 1. 0, 0, 1, 1. And then 8, +2. So we can get a few more points on this one. Remember with those cube roots, you can take the cube root of negative numbers. That is okay on this one. So we got 8, negative 2, negative 1, negative 1. So arrows on both ends because that will keep going to the left. It's going to keep going to the right. So what would our domain be this time? Everything, yeah. So x is an element of the reals. It's going to be everything. Range this time. Is also still going to be everything. It's going to take a while before it gets to be everything, but that right side is slowly going up. The left side is slowly going down. So it has the potential to be able to use everything. And there is no turning point here. Remember, your turning point is your vertex where it switches from increasing to decreasing or vice versa, decreasing to increasing. That doesn't happen here. This graph, if you follow it from the left side, this graph is always increasing. So we don't have a turning point on these because these ones are always increasing. Or if it ends up being reflected, it could end up being always decreasing. That is an option, but it's never going to be both. This one, we would have end behaviors on both sides because we have arrows on both sides. So our right side is going to positive infinity. And our left side is going to negative infinity, which is very similar to our odd degree polynomials that we did a couple units ago. All right, so take a look at that first example. What's our transformation that ended up happening here? To the right 2. That minus 2 underneath that radical sign means it's going to the right 2. So I'm going to take each point from my parent function. I'm just going to move them to the right 2. Still the same shape. Just move all those points to the right. So what's our domain going to be? Still XER. Moving that graph to the right does not change our domain whatsoever because it's still going to be everything. Range, still going to be everything. And again, we still don't have a turning point here. Our graph does not change from increasing to decreasing, which is what a turning point does. All right, example 2, we have 3 transformations this time. Let's see if you guys can remember the order. Which one happens first? Remember, it's the one closest to x is what happens first. Yep, horizontal movement. So in this case, it's going to be left 5. Then it will be the 2. Stretch by 2. And then the plus 4. We're going to move it up 4. So on my parent function, the first point that I'm going to deal with is 0, 0. I always start with that one. There's really no rhyme or reason. I just do. So I'm going to go left 5. 1, 2, 3, 4, 5. 0 stretched by 2, because you're going to use the y values when you do that stretch. So 0 stretched by 2 is still 0. And then I'm going to go up 4. 1. There's my final point. So again, that was my 0, 0. Left 5, up 4 is what ended up happening for that one. So my 1, 1, left 5. 1, 2, 3, 4, 5. Stretch by 2 means it's going to be multiplied by 2. So now I'm up here at 2. Again, it's the y, which is a 1, is stretched by 2, so it's up to 2. And then up 4. So I end up there. And then let's see here. I have my point 8, 2. So I'm going to go left 5. 1, 2, 3, 4, 5. I'm at a y of 2, so I'm going to double that. So I'm up at 4. And then I add 4 more. And I hit that. Go up. So then my -1, -1, left 5. 1, 2, 3, 4, 5. Double -1 puts me at -2. And then I move it up 4. 1, 2, 3, 4. And that's all that we're going to be able to get on there, because my other point at 8, -2, if I move it 5 to the left, I'm off the graph. So we're not going to really be able to plot that one. So our domain doesn't change. Range doesn't change. Still no turning point, because we don't switch from increasing to decreasing. Now, of course, yes, you could still use your calculator, get some points that way, but transformations are supposed to help you make it go faster.